Welcome everyone. Now as you can see that we are the Gen Z generation, right? If you're not my generation of 90s. Okay, so these are the generations of the computer. Never forget your past, right? Because it will always be going to be your building blocks to develop your future. And in this course we are going to do very much same thing. We are going to build a solid foundation no matter how much the world is going to change. Today it was AI, yesterday it was smartphones, day before yesterday it was computer laptops, day before that it was a way back story. But the fundamentals that we learn actually help us to develop ourselves in such a way that we can be a programmer. But what we can program the hardwares, we can program for the needs, for the inventions, and that is the limitless. That's why I named it computer science engineering and not just computer engineering, because computer science engineering, you are going through the science of that engineering that we have developed. So let's see that what are the generations of the computer. So this is the first one, vacuum tubes. Well, I hardly do think that most of my age people who are 20, 25, 26 years, even to that age, you have hardly seen the vacuum tubes. It was slow, it was huge, it was expensive, and what I have not mentioned here is it produces a lot of heat. And because of vacuum tubes, the size of the computer was a multi-story building. You can imagine that how much bigger it was. But something changed and transistors came. Well, don't go for this here, it is mentioned a bit incorrect, but let's leave that. Transistors. So what is transistor? Transistor is actually a device that changed the history, because as you can see that the programming language like COBOL and Fortran, which actually is the basis of the assembly language and programming languages, that actually allowed us to do what the vacuum tubes cannot do. I am also be interested in telling you that what was the problem with the vacuum tubes. Vacuum tubes actually was a great thing, but vacuum tube did not have one thing. Like, this is my vacuum tube, but you know what, I have thousands of vacuum tube. Now if I have thousands of vacuum tube and even 10 are not working, so if 10 vacuum tube actually failed in my 1000 vacuum tubes, so there are most likely be the chance that actually my machine is not going to function because its circuit broke. We all have seen this diagram that we used to make a battery and a bulb and we connect it and the light glows, but when it off or we break the circuit, it goes off. So that's the story of the vacuum tube, and that's why it was very much needed to create something new, and the transistors were born. So this changed, this reduced the size, not significantly but so much. It reduced the size from a multi-story building to the size of a few rooms at least. So this was a great invention. And now let's proceed to the third generation. And the third generation, something which is one of my favorite thing, actually came, integrated circuits. Well, integrated circuits or ICs are everywhere in the world. Everything that needs programming consists of IC. Like if you are having the AC, you are having a remote, and if you are having a remote, it is having an IC. If you are having television, definitely we all do have that. So it consists of integrated circuit. You are watching this course on any of the electronic device, like you are watching that on laptop or your palm top that we used to call as a pen. We are going to use to call it like smartphones and all that kind of device. You got my point, right? So that consists of IC. We program the IC. Yes, the IC itself is programmed to run the programs that comes to it. Well, we are going to understand this statement, don't worry. But this was the actual introduction of the integrated circuits, and I remember that integrated circuits. When I was studying that, it was one of my favorite topic in engineering. You might thinking it was programming, but it's actually integrated circuits. Not the third generation integrated circuits, of course, but integrated circuits. And let me tell you something very interesting. Integrated circuits in initial days is actually the set of transistors. Yes, that's why the transistors was very important, because in the first IC, there were 5 transistors in one IC, in very small, that can fit on a palm, so it's palm length, and 5 transistors are fitted into this. So that reduced the size even smaller, very small. So that reduced the cost and the power. That was our target. But it was not just the 5, because we are talking about the generation, so surely they have developed in this much years that they have added many transistors on a single IC or integrated circuit. That's why the name integrated circuit actually came. Now let me take you to the 4th generation, that is VLSI, very large scale integrated circuit. So what it actually do, as you might have already noticed, that this contains millions of transistors in just a small piece. And as you can see, this is our beautiful computer smiling. So how the multi-story building converted into a room, and that room into maybe a big table, and now our computer itself is on the table. That's why these are called desktop. I hope you get the point of desktop being desktop. Yeah, these days we call the laptops, smartphones and all that things, but this is the reason why they were called the desktop. And now I would like to take you to the final generation, which is 5th generation, in which we are actually living. That actually started in 1980s and going on and on and on. These are called as ultra large scale integration. That's basically the advanced version of VLSI, or simply integrated circuits. In this we have tens of millions of electronic components that were added together in a very small space. This much size, that's it. It can have 10 million, or actually more than 10 million, I can call millions, that's better, millions of electronic component into that. I used this image here to show the computer or desktop. This is pretty much similar to the above version that we have studied, like here, but you can notice that it used C and C++ programming, and I kept it similar, and this is for a reason, because C and C++ programming are the basis for the Windows. Well, if not others, it is definitely the basis for the Windows. Your PowerPoint, your WordPad, or your Paint, and so many things that we run on the Windows actually started with the Windows. Originally built in C and C++. So this was the power of 4th generation that created the 5th generation, that is our generation, so that we can work on even the artificial intelligence. You might be curious that is not there so much time, like even if we go through the date 1980 to till date, it means some 2024, it means 44 years somehow. So we have not developed anything. Yes, we have developed, we have increased the capacity of integrated circuits, but integrated circuits get so much complex that we were left with the option after this as quantum computers. That will going to be our 6th generation, but I have not mentioned it here because it's actually not available widely in the market. But at the end of the course, we are going to talk about the quantum computers. That's actually going to be the real future for a very long term and the 6th generation of the computers. So that's it for now. We have covered all the 5 generations of the computer, and I hope that you have actually enjoyed these generations of computer. See you in the next one. Take care.